Imagine you and your friends want to share notes for an upcoming exam. You could print them out and pass them around. Or you could connect your computers and share the files instantly. That connection is a computer network. A network is simply a group of two or more computers linked together. They are connected so they can communicate and share things. Think of it like a group of friends talking to each other. Instead of voices, computers use electronic signals. This simple idea has changed our world in incredible ways. It allows us to send an email to someone across the globe, watch a video from a server thousands of miles away, or collaborate on a project with teammates in different cities. The power of connection is what makes our modern digital lives possible. The main reason we build networks is to share resources. This is one of the most important goals. Resources can be things like a printer, a scanner, or a powerful hard drive. For any communication to happen, 5 components are essential. First, you need a message, the information or data you want to send, like an email or a picture. Second, you need a sender, the device that is sending the message. Third, you need a receiver, the device that is getting the message. Fourth, you need a transmission medium, for example, a copper wire, for example, a fiber optic cable, for example, the air for wireless signals. Finally, you need a protocol, a set of rules both sender and receiver agree to follow. Devices can communicate in 3 different ways, known as communication modes. The first is simplex mode. In simplex, communication is one way only. It is like a radio broadcast. The radio station sends a signal out, but it cannot receive one back from your car radio. A keyboard can send input to a computer, but the computer cannot send information back to the keyboard. The second mode is half-duplex. In this mode, communication can go in both directions, but not at the same time. A walkie-talkie is a perfect example. You have to press a button to talk, and while you are talking, you cannot hear the other person. Only one person can transmit at a time. This prevents the messages from colliding and getting scrambled. The third and most flexible communication mode is full duplex. Here, data can flow in both directions at the same time. A telephone conversation is a great example of full duplex communication. Both people can talk and listen simultaneously. Most modern network connections, like the one you are likely using to read this, are full duplex. This allows you to download information, like this web page, while also sending information, like a request for the next page. To measure the data we send, we use specific units. The smallest unit is a bit, which is a single 0 or 1. 8 bits make up a byte, which is enough to represent one character, like the letter A. A kilobyte is about 1,000 bytes. A megabyte is about 1,000,000 bytes. A gigabyte is about 1,000,000,000. A terabyte is about 1,000,000,000,000. Network speed, or bandwidth, measures how much data can be transferred per second. This is usually measured in bits per second. So a connection speed of 100 megabits per second means that 100 million bits can travel across the network every second. Higher bandwidth means faster downloads and smoother video streaming. Many different devices work together to make a network function. A modem, or modulator-demodulator, is what connects your home network to the internet service provider. It converts the digital signals from your computer into analog signals that can travel over the phone or cable line, and vice versa. A router is like the traffic cop of your network. It directs data packets to their correct destinations, both within your local network and out to the wider internet. A switch is a smarter version of an older device called a hub. While a hub sends every piece of data to every connected device, a switch is more intelligent. It learns which device is connected to which port and sends data only to the intended recipient, which reduces traffic and improves speed. A repeater is a simple device used to regenerate a signal. Over long distances, signals can weaken, a phenomenon called attenuation. A repeater receives the weakened signal, cleans it up, and retransmits it at its original strength, extending the range of the network. A gateway is a more complex device that acts as a translator between 2 different networks that use different rules or protocols. For example, it might connect your home's local network to the larger internet. Finally, a firewall is a critical security device. It acts as a barrier between your trusted internal network and the untrusted outside internet. It monitors incoming and outgoing traffic and blocks anything that looks suspicious or violates security rules, protecting you from hackers and malware. Data travels through a network using a transmission medium, which can be wired or wireless. Twisted pair cable found in telephone lines and Ethernet LAN cables consists of pairs of insulated copper wires twisted together to reduce interference. It is inexpensive but has limitations on speed and distance. Coaxial cable used for cable television has a central copper core surrounded by insulation and a braided metal shield. It offers better protection from interference and higher bandwidth than twisted pair. The best performing wired medium is fiber optic cable. It transmits data as pulses of light through thin strands of glass, making it incredibly fast, secure, and immune to electrical interference. But it is also more expensive. Wireless media transmit data through the air as electromagnetic waves, radio waves, AM radio, FM radio, Wi-Fi, Bluetooth. They can travel long distances and pass through walls, making them very convenient. Microwaves are higher frequency waves that travel in straight lines. They are used for long-distance communication between satellite dishes or cell towers. Satellite communication uses satellites orbiting the Earth to relay signals over vast distances, connecting remote areas. Infrared waves used in TV remotes are for short-range, line-of-sight communication and cannot penetrate walls. These different wireless technologies provide a range of options for connecting devices without the constraints of physical cables, each with its own trade-offs in terms of speed, range, and cost. Networks can be organized in different physical layouts, known as topologies. One of the simplest is the bus topology. In this setup, all devices are connected to a single central cable, called the bus. It is easy and cheap to set up. However, if the main cable breaks, the entire network fails. Also, since all data travels along the same cable, collisions can happen if two devices try to send data at the same time, which slows the network down. Another common layout is the star topology. Here, all devices are connected to a central device, like a switch or a hub. This is more robust. If one cable fails, only that one device is disconnected. It is also easier to manage and troubleshoot. The main weakness is that if the central device fails, the whole network goes down. A third layout, the tree topology, is a hybrid that combines features of the bus and star topologies. It has a root node, and other nodes are connected to it, forming a hierarchy that looks like a tree. Groups of star-configured networks are connected to a linear bus backbone cable. This structure is very scalable, meaning it is easy to add more devices and expand the network. It allows for easier management and fault identification in different segments of the network. However, its maintenance can be complex because of its size. Choosing the right topology depends on factors like cost, reliability needs, and the expected size of the network. For devices to communicate successfully, they must follow a set of rules called protocols. The most fundamental suite of protocols is TCP/IP. TCP breaks large messages into smaller pieces called packets before sending. It then reassembles them in the correct order and checks that nothing was lost or corrupted. Think of TCP as a meticulous shipping manager. IP handles addressing and routing each packet to its destination. It's like the postal service reading the address and delivering to the right house. Together, TCP/IP provides reliable end-to-end communication across the internet. Other protocols are designed for specific tasks. HTTP, or Hypertext Transfer Protocol, is used for viewing web pages. When you enter a web address, your browser sends an HTTP request to the web server, and the web server sends back the web page's files. HTTPS is the secure version of HTTP. The S stands for secure. The data exchanged is encrypted. This protects sensitive information like passwords and credit card numbers. For transferring files, we use FTP, File Transfer Protocol. For email, there are several protocols. SMTP is used to send emails. POP3, Post Office Protocol 3, is used to receive emails to your client. IMAP is also used to receive emails and sync them across devices. The internet provides us with a vast array of services. Email is one of the oldest and most widely used services. Instant messaging or chat services allow for real-time text-based conversations. WhatsApp, Messenger, VoIP, Voice over Internet Protocol, lets you make phone calls over the internet instead of a traditional line. Skype, Zoom. Video conferencing builds on VoIP by adding a live video feed for face-to-face meetings anywhere. All of these services rely on the underlying network infrastructure and protocols to function. The World Wide Web is one of the most popular services on the internet, but it's not the same as the internet. The internet is the global network of computers. The web is the collection of interconnected documents and resources on that network. To access the web, you use a web browser: Chrome, Firefox, Safari. Websites are collections of files like HTML code, images, videos. Those files are stored on a web server. This is web hosting. As our lives become more connected, keeping our information safe becomes more important. This is the field of cybersecurity. Cyber law refers to the legal rules and regulations that govern how we use the internet and digital technologies. It addresses issues like intellectual property, privacy, online fraud. A cybercrime is any criminal activity that involves a computer, a network device, or a network. Examples include hacking into someone's account, spreading a computer virus, stealing financial information online. Understanding these concepts is the first step toward protecting yourself in the digital world. It's about being aware of risks and taking sensible precautions. There are different types of people who try to break into computer systems. A hacker explores systems and networks, sometimes to test security or find vulnerabilities. Their intentions can be curious or malicious. A cracker breaks into systems with clear criminal intent to steal data or cause damage. To protect against these threats, we use tools like firewalls. A firewall acts as a protective barrier, filtering network traffic to block unauthorized access while permitting legitimate communications. It's one of the first lines of defense for any internet-connected device. You may have heard of cookies. A cookie is a small text file a website stores on your device. Cookies can remember preferences, keep you logged in, or personalize your experience. For example, an online store might use a cookie to remember your shopping cart. But third-party cookies from advertisers can track you across sites. That tracking can be a privacy concern. Most browsers let you view, manage, and delete cookies to control your digital footprint. Another important concept is remote access. Remote access is accessing a computer or network from a different location. Used by system administrators to manage servers remotely. Used by employees to work from home. But remote access can be a serious security risk if not secured. An unsecured remote connection can act as a backdoor for attackers. Use strong passwords, use encryption, and enable two-factor authentication. Balance convenience with security to let authorized users in while keeping attackers out. When you face a network design problem in an exam, break it down with a simple strategy. First, determine the type of network needed. Is it for a single room or building? You need a LAN or local area network? Does it need to connect a few buildings across a city? A MAN or metropolitan area network? Is it for connecting offices in different countries? You will need a WAN or wide area network. The size and geographic scope of the project are your first clues. A LAN is small, typically owned by one organization, and uses technologies like Ethernet. A WAN is large, often uses leased telecommunication lines and connects multiple LANs. Next, choose the topology and medium. For a small, low-cost LAN, a bus topology might seem simple, but a star topology is almost always a better choice today. You would use a central switch. For the medium, twisted pair Ethernet cable like Cat6 is the standard for most office LANs. If you need very high speed or are connecting buildings, fiber optic cable is the superior, though more expensive, choice. For user convenience or in areas where running cables is difficult, a wireless solution using Wi-Fi is perfect. The key is to match the pros and cons of each option to the scenario's requirements for speed, cost, and reliability. Then, decide on the placement of servers and the necessary network devices. If the organization needs to share files and applications, you will need a dedicated server. Placing it in a secure, climate-controlled room is best practice. Think about the devices needed to connect everything. You will need a modem to connect to the internet. You will need a router to direct traffic. You will need switches to connect all the computers, printers, and other devices within the LAN. If you are connecting multiple network segments or need to protect the network from outside threats, you will need a firewall. For large areas, you might need repeaters or multiple wireless access points to ensure strong signal coverage everywhere. Exam tips checklist. Know LAN/MAN/WAN, master topologies, remember key protocols, learn device roles. For data units, remember 8 bits equals 1 byte. know the hierarchy: kilo, mega, giga, tera. For network types, remember LAN is less than 2 kilometers. MAN is less than 50 kilometers. WAN covers a country or even the globe. Key protocols to know: TCP/IP, the foundation; HTTP for websites; FTP for files; SMTP for sending email; for topologies, associate bus with a single cable; star with a central device; tree with a hybrid structure. Remember that a switch is smarter than a hub because it sends data only to the destination port. A router connects different networks. A firewall protects the network. By understanding these core concepts and how they fit together, you can confidently tackle any question that comes your way. You have the tools to understand and design the networks that connect our world. Keep learning, and you will succeed. We've covered the fundamentals of computer networks, from basic communication principles to advanced security concepts. These concepts form the foundation for understanding how our connected world operates. With this knowledge, you're prepared to excel in your studies and contribute to our networked future. The networks you understand today will shape the innovations of tomorrow. Your journey in computer networking starts here.